In the immortal words of James Brown,
get on up. But I think I'll take him to the bridge. 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 All right, if I take him, Joe. Yeah. Take him to the bridge. Yeah. One time.
ha! That's real. Well, hey, real fans, welcome back to my hobby room to the Brownsmith Railroad, where today we're going to take a look at how I scratch built an in-scale girder bridge that's 80 feet long, scale feet long, out of styrene plastic. To get started, I went online and I looked at some examples of prototype girder bridges, and I settled on these two examples to use as inspiration. Mine's going to look similar to that, but not quite like that because I'm just a regular guy and I build it like I build it. One of the other things I found though was this totally cool engineer's drawing of how to build one. It's amazing. Now I've got to convert all the feet and inches into scale feet and inches, but I got an in-scale ruler to do that. So I put the image in my head and then I bought a bunch of plastic and set off to build what I'm about to show you. I waited like 2 weeks to get the styrene that I wanted. And you know, truthfully, it's been a while since I did something from styrene. And so I ordered a bunch of 060 and 080 thick sheets and some I-beams and some bar stock. The thing is, I'd forgotten how thick 060 and 080 is. So I went out and waited another almost 2 weeks to get some much thinner stuff, which, as we're gonna see, is a blessing and a curse, and there's a little tip I'll give you moving forward. So anyway, once I had all the pieces I needed, I put my scale ruler down on the 020, which is what I used, because according to this drawing, the bottom plate for the bridge is supposed to be 3/4 of an inch. Now, 3/4 of an inch in scale is like a human hair, all right? I can't get 3/4 of an inch. So I used my 020 to do that. It's very thin. It's almost like plastic paper, but it served its purpose. Again, later on, we're going to discover that was a bad idea. But for now, let's move on. I measured the width of this stock that I got, and it was nearly 80 feet. It's like 79 and a half scale feet wide. I'm like, I'm just a regular guy. That's going to work for me. Now, according to the engineer's drawing, which I have printed out right in front of me, the width of this thing needs to be 23 feet 9 inches. Now, inches and in scale are not inches, as I just told you. So I picked something that was close to that. I think I ended up with 23 feet 6 inches. Who's gonna know? It's in scale. And I made a mark on both ends as exact as I could for two reasons. One, I want it straight. But two, whatever I lop off is now the straight edge for what I cut off later. You're gonna see that in just a minute. So I went ahead and I cut that out and I scored it with the back of the blade. Many of you guys know this technique. You score it to remove plastic rather than cut through it. I did that to start off with, but it still left a little bit of a bird edge that I had to go through and file off. And then later on, I realized that's a fool's errand. I just started cutting through the plastic, as you'll see moving forward. Once I had the base cut out, now it's time to put in the I-beams that you see here on the drawing. Now, the funny thing is, this drawing says that those I-beams need to be 2 foot 6 inches on center for the length of the bridge. Now, truthfully, you're never gonna see these. I almost could have got away with not putting them in, but the bridge itself for my train needs some kind of structural support. So I went about every 10 feet doing that. I cut out pieces that were the width of the deck, aligned my chopper to be able to do that, then just chopped off a whole bunch of 060 I-beam pieces. Now, here's another thing that you guys already know, but just to be thorough, the glue I'm using, when I line the piece up where I want it, I run a bead of glue down there, but then it's got a minute or so where it's kind of sloshy. It's kind of like melted butter. And so what you can do is line the piece up. You'll see here I turned it on edge and then used the back of my X-Acto knife blade to push it down onto my workbench to make sure it was square all the way across. After that, I took all the rest of the pieces I cut, I glued them on again about every 10 feet till I got to the end. Now, according to the engineer's drawing, the webs on the side of the girder bridge need to be like, what, 9 feet, 2 3/4 inches. I didn't get the 3/4 inches. All right, I'm just telling you. And a nice easy dimension for me was 10 feet. So I cut out some 10-foot strips that were nearly 80 feet long. Then using my right angle magnets, snapped them in place on each side, aligned it, and then went ahead and put the glue on. Now, again, the glue is a little smushy for a while. So I really wanted those I-beams, as you're gonna see why later, those I-beams to sit right at the bottom of that web plate. So with the glue on there, it gave me a little time to manually push all those pieces into place. You know, in case I fail to point it out later, those side pieces I glued on, no matter what I did, they still weren't quite square. There's something I came up with that's a feature on the bridge. It's a detail, but it's also integral to the structure, where I was able to align that. We're gonna take a look at that in a minute. And that's what it looks like with the webs glued to the deck. Like I said, I didn't go every 2 foot 6 inches on center for those I-beams. I just need enough to give it some strength, because as you see, when I put the tops and bottoms on, you're not gonna see those I-beams anyway, so why bother? Now it's time to cut and glue in what the drawing calls a knee brace. It's basically a triangular piece of metal, or plastic in my case, that sets a right angle and then stiffens that web plate, which I use for double duty. One, to align the edge of that web so it's at a right angle with the deck. And also it does actually give the scale version of this some strength for a train to pass over. I cut them 9 feet tall by 5 feet wide, then went corner to corner with my X-Acto knife and just cut them into triangles. Okay, so look, here's the deal. This is really small. My hands are really big. So the next few shots may not give you glorious detail of how I did this, but the summation is I took some tweezers, the triangle piece, got it kind of where I wanted it, then put glue on it, and then manually just aligned everything and squeezed it together until the glue set up. I had to redo a couple of them because I didn't realize like it was this way or it was this way or something. So it took some time, but it's a labor of love, and it's part of what I love about the hobby is scratch building stuff. Okay, once I had all those knees in, I went through and I glued in the stiffener plates. Now for that I used 020 by 030 styrene, approximate dimensions that fit the engineer's drawing, but they're not exact, people, all right? I just made this crap up as I went along. Anyway, what I tried to do is glue them on right behind those knee braces, so it almost looked like one piece going through there, even though it's not, it's two pieces. But I wasn't so concerned about the length. I needed to get it close. It was hard enough to line this up and get it plumb, square, looking good, the whole 9 yards, okay? Later on, you're gonna see I went through and I snipped off all the tops and I filed everything smooth before I moved forward. Okay, now it's time to cut out and glue on the flange plates. Now, what I did is I just measured about how wide I wanted these. I don't know for certain even what I came up with. I kind of eyeballed it. And then cut a long strip and then started at one end and eyeball centered it and just kept gluing my way down until I got to the other end. None of it's ideal, but in some cases I actually had to take the web and tweak it a little here, tweak it a little there. Again, eyeballing this all the way down to get it straight. When you look at the finished bridge, it's pretty square. You can't tell I did that. So this is not a bad technique. Instead of trying to get it perfect, get it close and then give it some love, like a love machine. When I'm putting the top plate on, the flange plate, it wasn't quite 90 degrees to the web itself. So while the glue's drying and I'm desperate, I flip the thing over on its top to sort of make two right angle surfaces, one flat on the workbench, the other one at a right angle to that. That worked, but at the same time discovered there was still warble in the web. So you'll see here, I've just taken my file and just pushing things into place to get it lined up as close as I could. And there you go. Now here's the thing, the bottom plate of the girder is what the I-beams actually are supposed to in real life sit on. So I just glued that bottom piece right in. And then for a little, it seemed like it needed more detail. So just on my own, for the hell of it, I took a 020 by 020 strip and just glued it to the center of all those knee plates. It gives it a little extra dimension, a little extra interest. I don't know how much of that you'll see once it's all painted and detailed, but overall, I like the way this is turning out. Oh, by the way, something else. Even though I built all this with all these cross members and all this junk in there, the bridge still flexed in the middle some kind of way. And here's that tip I told you I'd give you. I used the 020 styrene for the deck because it was as close to 3/4 of an inch that I could get. The problem is, you're not gonna see that deck plate on the edge. You're not gonna know how thick it is. I should have gone 080 or 060, something stiffer. But I didn't because I'm really trying to stay to the prototype, which, you know, sometimes we should do because we're modeling prototypes. On the other hand, if it's not practical, then who gives a crap? But anyway, what I did to compensate for that is I cut me some long I-beam pieces and just glued them across the bottom. You're not going to see those I-beam pieces, but it did add quite a bit of stiffness to the bridge. So this is going to be what I believe they call a crossover bridge. What that means is the bridge gets built, and then when they're laying the track, they just ballast right over the bridge and lay the rails right over it. So to give me a head start on that, I decided to install cork roadbed now, so it's already affixed to the bridge. And so basically it's easy. I just measured and cut it, and then I had to cut the roadbed a little thinner. I'd take a slice off of it because it was too wide to fit between the knee braces. Once the cork roadbed was the correct size, basically just took some wood glue, coated the bottom of it and stuck it down. I used wood glue so that later on when I'm ballasting this thing and I put a bunch of alcohol on top of it, it doesn't sort of spring that cork roadbed from the plastic. I'm also hoping that as I move forward that the ballast and everything I put on there will indeed stick. If not, I'll be the first one to say I blew it. Well, there it is for now in a mock-up scenario where I've got my UP locomotive sitting right on top of it. Now, just like the wooden bridge, I've got to go through and weather it, detail it, and all that stuff. But for now, I just wanted to get my two bridges done so I can start working on the gorge they're going to be sitting over, which hopefully you'll see in the next video. One other thing here, you know, it took me, it may be, I don't want to exaggerate, maybe 40 hours to glue all the little pieces together for my wood bridge, all right? About halfway through, I'm like, what the hell am I thinking? You know what I'm saying? But this one, I spent 4 hours on a Friday night, 4 hours on a Saturday morning, and the bridge was built. Fewer details, fewer pieces to cut, still looks good in my humble opinion. So anyway, that's how I pulled that off. Hope you got some tips or some encouragement from that. And until I see you next time, my name is Steve Brown. Rail on, my friends.